Assalamualaikum and hi everyone. So we are from Group 10. We will make a presentation about our project topic, which is the pipe network using Hardy cross method. My name is Nur Atika Bashira binti Amizar. So I will present about our introduction of our project. First of all, Hazen-Williams formula is described as when water is flowing and the flow is turbulent, and Prickle equations are frequently employed to compute the approximate head loss in a pipe. Because of the comparatively simple calculation necessary prior to advent of personal computer, the Hazen-Williams formula was particularly popular with engineers. Unfortunately, the results are depend on the value of the fraction factor CHW, which can range from roughly 80 to 130 and higher depending on the pipe type, pipe size, and water velocity. For the calculation, using the Hardy cross method together with Darcy-Weisbach and Hazen-Williams method, we will conduct an analysis of the Q emission necessary in each pipe of this water delivery system in CTA. Figure 1.1 specifies the pipe length and diameter. Table 1.1 lists the intake and exit discharge, which is for Q inlet E are 100 L per S, Q outlet A is 30 L per S, G is 20 L per S, H is 20 L per S, and J is 30 L per S. The loop that involved in our calculation is loop 1, loop 2, loop 3, loop 4 by using Hazen-Williams equation for head loss. For the information of pipe, Table 1.2 and Figure 1.2 as shown below describe the pipe number, length in meter, diameter in meter, friction factor F, and value of Hazen-Williams constant that involved in our calculation. Next, I will pass our presentation about the detail of the calculation to the next presenter. Thank you.
Hi, Assalamualaikum. My name is Nur Hazika binti Muhammad. My number matric is BF210401. Today I would like to present about the calculation for loop 1. In each loop, we need to calculate the value of K, H, H over Q, and lastly is the DQ using the different formula. In loop 1, we assume the flow rate for pipe 1 is 10 liter per second. For pipe 2 is 40 liter per second, and for pipe 3 is 20 liter per second, and lastly for pipe 4 is 10 liter per second. The assumption of flow rate, we use it for trial 1 to get the DQ and repeat the same step until the value of DQ become 0. For loop 1, we managed to do until trial 6 to get the value of 0, and we also get the final correction for each pipe, which is for pipe 1 is 1.4412 liter per second, and for pipe 2 is 31.4412 liter per second. Pipe 3 is 28.55x7 liter per second, and for pipe 4 is 18.55x7 liter per second, and the same calculation will be done in each loop. So that's all from me. Thank you.
My name is Nur Atasha binti Zakaria. I will explain my part, which is part calculation of loop 2 and loop 3. For loop 2, for an example at trial 1, our first assumption for pipe 3 was positive 20. To calculating the K using the formula of 10.67 times by length divided by constant value power 1.852 times by D power 4.87, and we got the answer 0.1231. Then we need to calculate the H that K needs to time with Q power by 1.85, and we got the value of 31.6097. Next, we need to calculate the H over Q, and we got the answer 1.5804. For the delta Q2, we got the answer negative 10.1716. In this loop 2, we end at trial 9 that we already got the value of 0.0006. So we got the result with 3 value of anti-clockwise and 1 value of clockwise. Next was loop 3. For an example at trial 1, our first assumption for pipe 4 was positive 10. To calculating the K using the formula of 10.67 times by length divided by constant value power by 1.852 times by D power 4.87, and we got the answer 0.012733, and we need to calculate the hash that K needs to times by Q power 1.85, and we got the answer 0.9056. Next, we need to calculate the hash over Q, and we got the answer 0.0905. For the delta Q3, we got the answer negative 0.90809. In this loop, we end at trial 9 because at loop 1 and 2, we already got the answer 0.000. So we got the result as shown as in slide.
Assalamualaikum warahmatullahi wabarakatuh. I Nur Hazrin Ivy Nabila binti Muhammad Zuhairi, matrix number BFC10403. would like to present about the calculation for loop 4. In each loop, we need to calculate the value of K, H over Q, and lastly the Q using the different formula. In loop 4, we assume the flow rate for pipe 10 is 5 litre per second, for pipe 11 is 20 litre per second, for pipe 12 is 10 litre per second, and lastly for pipe 3 is 5 litre per second. The assumption of flow rate, we use it for trial 1 to get the DQ and repeat the same step until the value of DQ becomes 0. For loop 4, we managed to do until trial 5 to get the values of 0, and we also get the final correction for each pipe, which is for pipe 10 is 4.6673 litre per second, pipe 11 is 20.3326 litre per second, pipe 12 is 9.6673 litre per second, and pipe 13 is 5.3326 litre per second. The same calculation will be done in each loop. For the calculation, the study is being done to analyze the discharge queue in each pipe of the town A's water delivery system. Pipes in municipal distribution system are commonly interconnected, allowing multiple channels for the flow to an exit. As a result, we often cannot identify by inspection which way the flow moves, as in pipe network given. We use the Darcy-Weisbach head loss equation, which require a series of consecutive approximation and correction to flows in individual pipes, in place of the Hardy-Cross method that have been suggested to tackle the problem for our project. At trial 6 and final trial 5, the algebraic total of the head losses around loop 1 and loop 4 resulted in 0. It was due to the non-linear relationship between the head loss in a pipe network and the flow rate. It is clear that a single simultaneous linear equation cannot adequately explain the network system. The Hardy-Cross approach demonstrates how we can broaden our understanding of our fluid mechanics concept to handle pipe network in loop configuration.